This is part 2 in a series of videos about testing a claim of population mean. In part 2, we'll review how to find the p-value given the sample size and a test statistic. One of the methods is use the graphing calculator, Ch8-3 or Ch8-4. In the graphing calculator, we will go to second, click vars, then find t-CDF. Then we'll need to enter three things: the starting point, the ending t-value, and degrees of freedom. Either the starting point or the ending value or the ending point can be negative or positive infinity. The claim is that for a smartphone carrier's data speed at airports, the mean is mu equals 10 megabytes per second, the sample size is 32, and the test statistic is equal to negative 2.816. First, we need to determine the type of the test. For a left-tailed test, the p-value is the area on the left of the test statistic. For a right-tailed test, the p-value is the area to the right of the test statistic. And for a two-tailed test, the p-value is twice the area in the tail beyond the test statistic. The claim is that mu is equal to 10 megabytes per second. So this will be our null hypothesis, since it has the equal sign. Mu is equal to 10 megabytes per second. Our alternative hypothesis, H1, will be that mu is not equal to 10 megabytes per second. Remember, the sign of the alternative hypothesis will determine whether the test will be left, right, or two-tailed. Since it's not equal sign, let's draw a picture to help us visualize. This is our t distribution, which is pretty close to the normal distribution with the zero in the middle. So alternative hypothesis has not equal sign, therefore our p-value is going to be located in two tails. We're given the t-statistic on the left side. The t-statistic here is negative 2.816. On the right side, we can assume it's going to be the same value, just positive. We also need to find degrees of freedom for the test statistic. Remember, degrees of freedom is n minus 1. In our case, degrees of freedom is 32 minus 1. Degrees of freedom is 31. And finally, let's use the graphing calculator. In the graphing calculator, you're gonna go to second, vars, then go down to t-CDF, click enter, and if you have Ch8-3, you might have to enter three values in the parentheses. First is the starting t-value, starting point. Second is the ending t-value point, and finally degrees of freedom. In this case, let's look at the left tail. The left tail start with negative infinity. So in the Ch8-3, you will enter negative 99999, or you can enter negative 1e99. When you enter negative 9999, make sure to use this button, negative, and not the minus sign. Otherwise, it will show the error on the calculator. We start with the negative infinity, or negative 99999. upper side is negative 2.816, negative 2.816, degrees of freedom 31, click calculate, click calculate. Here's our beginning point, the ending point, degrees of freedom, enter, and our p-value on the left side is negative 0.00419. Let's round to 3 decimal places. P-value is 0.004, but remember, we had a two-tailed test because our alternative hypothesis has a non-equal sign. Therefore, we will need to multiply our p-value times 2. And we get that p-value is equal to 0.008 in our case. That we are familiar with the graphing calculator option, let's look at another option using the StatCrunch. In the StatCrunch, you will go to Stat, Calculators, then choose T. Let's look at the StatCrunch program. Look at in the same example. We go to Stat, Calculators, and we have a whole bunch of calculators. We choose T. Here's our T distribution that looks like normal distribution. Change the degrees of freedom to our degrees of freedom 31. Probability for X is less than, our t-statistic is negative 2.816, negative 2.816. Oops, make sure to write it in the right box. Negative 2.816, and click compute. And again, the p-value shown on only left-tailed. And since we have two-tailed test, we'll need to multiply this p-value times 2. 0.004 times 2 will give us again a 0.008.